Number 242. So on 242 it says, the graph of f of x is shown below. Which function could represent the graph of f of x? And we're given 4 choices. Since you're given a graph and then you're given equations, I would say the best thing to do is to put each of these possible answers into the calculator and see which graph matches the one that we were given on the page. So in my calculator, I'm going to start with number 1, x plus 2, close the parentheses, x squared plus 3x, subtract 4, and hit enter. Now when I look at this picture, yeah, it pretty much looks like the one that we were given on the screen. It's got a, goes up on the left, and then it goes down on the right, and then it goes up. But I'm going to add some more graphs on here just to make sure that that's the right one. I can Control G to bring up that box again. And I'm going to put another graph right on top of this one to compare it and see if it looks any better. So I'm just typing in number 2. And when I look at it, ooh, it looks like it goes up on the left and down on the right. And yeah, this turnaround spot, that vertex over there, just doesn't look like the one on my graph on the paper. So I'm going to delete the red line and say, nope, that one's not right. So get rid of all of it. And I'm going to try choice 3. X plus 2, parenthesis, x squared plus 3x plus 4. Yeah, that definitely doesn't look like what is on our paper. So, nope, choice 3, not right. So I'm going to delete that and try choice 4. X minus 2, x squared plus 3x plus 4. Definitely doesn't look like what's on the paper. It doesn't even go up and down. This red new line for number 4. Yeah, that's not the right answer. So the correct answer was our first line, the blue one, of x plus 2. Need my markers. X plus 2, x squared plus 3x minus 4. It's the only one that looked like the graph that they gave us. 243. So we've got which equations represent the graph below. We are given 3 equations, and then we're given a picture, pretty much the opposite of what we just had. Well, if we're given equations and we have to match a picture, go to your calculator. So let's see, the first equation is x plus 2 parenthesis, x squared minus 4x minus 12. Does this look like the original? Goes up on the left side up to like near 8. This one doesn't do that on the left side. It doesn't go up here over by the 8. Number 1, not the right answer. So we can go in and we can eliminate choice 1. Roman numeral 1, not the right answer. So process of elimination, eliminate answer 1 and answer 3. So now we need to know if option 3 works or not. So let's see, delete my graph, type in my new one, minus 5x minus 6. Does this look like the graph we were given? Well, kind of. I mean, it goes up pretty high. Does it go up as far as this one? I don't know. I want to see this a little bit better. I want to zoom out on this. So I hit menu, zoom out. Kinda, maybe. Okay, so once I zoom it this far, I can see that the top crest over here on the left side, it's kind of little versus the bottom part that goes down really far. The one we were given goes high on the left and just a little bit low on the right. So these two, not matches. So our only choice is option number 2. That's the only one that worked. So for our answer, Roman numeral 2, 2 only. (244). The graph of y equals ax squared is shown below. If a is multiplied by -1/2, the graph of the new equation is wider and opens downward, wider and opens upward, narrower and opens downward, narrower and opens up. Okay, so given these choices, it's telling us that if we stick a 1/2 or a -1/2 right there in for A, it changes the graph. Well, let's look at what the graph would look like on our calculator. So if we had a negative, I forgot my negative, a -1/2 before the x squared, how does it affect the graph? Well, the first way that it affects the graph is that obviously it turns the other direction. So instead of being a U shape, it's an upside down U. So it's opening downward, we would say. So now it's to choice, let's see, downward. Choice 1 or choice 3. So I'm going to eliminate 2 and 4. Is it wider or narrower? My original's kind of skinny. My new one's kind of fatter. So that would be it's wider and opens downward. (245). Oops. There we go, sorry about that. How does the graph of f of x, 3 parentheses x minus 2 squared plus 1, compare to the graph of g of x, which is x squared? Well, if we're comparing two graphs, let's see what the two graphs look like. Let's graph both of them. So the first graph is 3 parentheses x subtract 2 parentheses squared plus 1. Okay. The second graph, I control G to bring up my box again, is x squared. So alright, I wanna play with my scale a little bit. Let me make that top be a 10. Alright, that's pretty good right there. I can make a comparison now. So my f1 is the f of x, and my f2 is the g of x. So it says, choice 1, the graph of f of x is wider than the graph of g of x. Is, let's see, this is where it's going to get a little complicated. Is my first graph wider than my second graph? No, my first graph is actually skinnier. So choice 1, not it. The graph of f of x is narrower than the graph of g of x. So f is my blue one. Yeah, that's narrower, that's skinnier than my red line. And its vertex is moved 2 units right and 1 unit up. So let's see, 2 units right and 1 unit up. Let's see, so my vertex for F1 is over here. You know what, I want to zoom in on this again. I'll just use zoom. Menu, window, zoom, zoom in. Okay. So is the graph of f of x moved 2 units to the right and 1 unit up? So here's where a little bit of Englishy kind of reading comprehension stuff comes in. So we need to figure out, yeah, it kind of looks like these are right and left and up from each other. Whoops. There we go. But when it says its, what is its? I don't like how they worded this problem. And its vertex, does it mean the first graph or the second graph? So let's see if we can figure that out. How does the graph of f of x compare to the graph of g of x? How does the graph of f of x means that this its is f of x? F of x's vertex, is that moved to the right 2 units and up 1 unit? This is completely backwards than how I would have interpreted it. So is the vertex of f of x, our blue line, 2 units over and 1 unit up? I'm going to move my graph back to standard because it messed up my, there we go, my scale along the bottom. Is it over to the right 2 units? Yes, if I look at x squared and I go over to the right 2 and up 1, I'm at my vertex for f of x. So that means that yes, 2 is the correct answer. The vertex for f of x is indeed moved over 2 units and up 1 unit to get my f of x. The g of x is over 2, up 1 to get f of x. 246. In the diagram below, f of x is x cubed plus 2x squared is graphed. So that is the top line. Also graphed is g of x, the result of a translation of f of x. Translation means that they kind of slid the graph. They moved it. They just took the same graph and they pushed it over or up and down. Determine an equation for g of x. Explain your reasoning. All right, so before we get into the whole figure out the equation thing, I want to know what has happened to the graph. How has it changed? So f of x is up here, goes up and down. If I take that same mark I just made and copy it, okay, there we go. They are moving the graph down. So it's taking this graph from up here and they're sliding it down. How far did they slide it down? Well, this low spot started at 0 and it goes down to -4. Okay, well, it moved down 4. How could that possibly affect our equation? All right, down 4, down 4, down to -4. Maybe there's a -4 in there somewhere. Let's go over to the calculator and kind of see if the calculator could help us figure out what that equation should be. So I know that the f of x is x cubed plus 2x squared. Oops, it went in wrong. It went in with too many things as the exponent. Plus 2x squared. There we go. So yes, that matches my top equation. All right, -4. Somewhere in there, the graph moves down 4. So maybe I want to just like stick a -4 into the equation. So that would be x cubed. Move my cursor over. Plus 2x squared. We need that same start of the equation because it really is the same picture, just they moved it. So what if I stick a -4 into the equation? What has happened with my blue line and my red line? Is my new f of 2 the same graph but moved down 4? Well, yeah, this low spot has indeed moved down 4 lines. Just like over here, the low spot moved down 4 lines. So my new equation, g of x, I almost started to put an f, g of x equals x cubed plus 2x squared minus 4. It kind of looks like putting a -4 into that equation made the graph move down 4. I could have tried putting maybe a -4 into an exponent. It wouldn't have looked very good, but you know, it's something we could have done. We could have tried putting a -4 in as part of the x and had like x minus 4 squared. Explain your reasoning. Well, putting a -4 into the original x cubed plus 2x squared made the graph move 4 units down. So explain your reasoning means you need to figure out how to say what you did. You could go into, I put the original into the equation and I played around with numbers to make it move 4 units down, and a -4 at the end is what worked. $247. I actually want to skip 247 and come back to it. I want to do 248 first. So go ahead and flip to 248. It says the vertex of a parabola represented by f of x as x squared minus 4x plus 3 has coordinates of 2, -1. So that 2, -1 is the vertex. Find the coordinates of the vertex of the parabola defined by g of x equals f x minus 2. Explain how you arrived at your answer. The use of the set of axes below is optional. So they're saying, hey, you could figure out the answer with some sort of graphing, but you're not required to graph to figure out the answer. I'm going to kind of combo it. I'm going to use the graph and I'm not going to not use the graph. So this is saying, all right, we've got some function rule f of x. We've got a new function rule g of x that is f of x minus 2. This x minus 2 means it gets inputted everywhere where there's an x. So my g of x equation is kind of similar to the f of x, except everywhere where there's an x, instead it's an x minus 2. Oops, I lost my pen. There we go. So I'm keeping everything from the original f equation, but I'm substituting an x minus 2 in place of x. Now I'm going to do some distribution and some multiplying and stuff. X minus 2 squared means, hey, make that box x minus 2, x minus 2, fill in the inside, x squared minus, 2x minus 2x plus 4. So my g of x expression becomes x squared. Maybe I better just type this. X squared minus 4x plus 4, and then bring down everything from the top. Or you know what? Wait, there's distribution happening here. -4 times x, -4x. -4 times -2, +8. And plus 3 drops. There we go. Find your like terms. X squared doesn't have any like terms, so equals x squared. Get that out of the way. X's, regular x's. This -4x and the -4x combine to make a -8x. And then we have a 4, an 8, and a 3. They combine to make a 15. I can now graph this x squared minus 8x plus 15, to figure out, hey, what's my vertex? So I'm going to add a graph. I'm going to graph x squared minus 8x plus 15. Okay, so we could either look at this graph and we could Control T to bring up our table, and we could graph all of these points onto the graph paper and then figure out what the vertex is. Or I'm going to show you something that the calculator can do. I'm going to get rid of this table. Come on, Control T. In Menu, in Analyze Graph, there's a minimum and a maximum in here. So what we can have the calculator do for us is tell us what this point is, this vertex. Is this a minimum or a maximum for the graph? It's the lowest point, so we're going to select minimum. I click on one side, I drag it over, and the calculator tells me that 4, -1 is the vertex. So when it says over here, find the coordinates of the vertex, well, we found the vertex. Explain how you arrived at your answer. You have to write something. So over here I'm going to say the vertex is 4, -1. I found my answer by substituting, there we go, x minus 2 into f of x. I then graphed x squared minus 8x plus 15 in the calculator. The vertex is a minimum, so I used the minimum from the menu to get the vertex. If you chose to graph it on the graph paper provided, you would say I graphed of x squared minus 8x plus 15 onto the graph paper and found the vertex. So now knowing this, I want to go back and look at the last one. And get rid of this. Okay, so this one says Richard is asked to transform the graph of b of x below. The graph of b of x is transformed using the equation h of x equals b of x minus 2, and then subtract 3. Describe how the graph of b of x is changed to form the graph of h of x. Okay, so it says that this graph right here is b of x. We want to know if we take function b, if we take this graph of b, and we do some numbers to it, some -2 and some -3, what effect is it going to have on the graph? So we're going to kind of combine two different problems together to figure out, all right, this -2 is inside of the parentheses. What effect does that have on the graph? This -3 is outside of the parentheses. What effect does that have on the graph? So let's start with the -2 that's inside of the parentheses with the x. I'm going to go back to 248. When we had f of x minus 2, okay, what effect does that have on the graph? Oh, I deleted my last graph. That's okay, I'm going to put it back in there. So my original graph is x squared minus 4x plus 3. So there's my original f of x graph. My new graph is the one that we figured out. X squared minus 8x plus 15. So let's look at these two graphs, my original, my new one. What has happened with this x minus 2 that's inside the parentheses? Where has the graph moved? It looks like the graph moves over 2 spots. It's 2 lines over. And which direction is it in? All right, it's to the right. So when there's a -2 inside of the parentheses, the graph moved 2 units to the right. I bet that if it was a plus, the graph would move 2 units to the left. Well, what do we have in this problem? An x minus 2. Oh, it's still an x minus 2, just like the other one. So minus 2 means it moves 2 units right. Describe how the graph of b of x changed. It's 2 units right. And now we'll figure out what effect that -3 has. So the negative 3 we kind of looked at with 246. I'm going to go back. Remember this one where we had our original and we said, all right, this is down 4. What is going to make the graph go down 4? We stuck a negative 4 at the end of it. In 247, there's a negative 3 at the end of it. All right, well, we put a negative 4 and the graph went down 4. So if we have a negative 3, the graph goes 3 units down. Describe how the graph of b of x changed. The x minus 2 makes it go 2 units right. The minus 3 makes it go 3 units down. Inside of the parentheses, you kind of would think an x minus 2, that would make it go to the left, because that's the negative side. But actually, it's kind of backwards, and a negative 2 makes it go to the right when it's inside of the parentheses. And a negative 3 still makes it go down. So that answers 247.